solve paper 1B questions today. Let us start with May 2025 question. So this in this question, a student is analyzing a sample of water. Basically, he is finding out density. Now, of course, to know density, he must measure its mass and the volume. So the first question is about identify one way to ensure that the volume is read accurately. Very simple. The answer would be that your eyes should be leveled with the reading, right? So if you just write one mark, like 1 point, this is enough over here. Eye leveled with the reading. This is the simplest one. Cool. Now let us move further. In the second part, they have given the value of volume and mass, and they want us to calculate the density of the sample and its absolute uncertainty. Cool. So volume is given with its absolute uncertainty. So I can say V plus minus delta V is given, and M plus minus delta M is given, where V is 10.6 and delta V is 0.2, right? Similarly here, M is 10.82 and delta M is given 0.01. So V is given with its absolute uncertainty, M is also given with its absolute uncertainty. So we are supposed to calculate the density and its absolute uncertainty. Okay, so let us start with the density. So density is given by mass over volume, right? So the mass given is 10.82 grams, volume given is 10.6. So if I divide it, I get somewhere around 1.02 gram per centimeter cube, because my mass is in the gram, volume is in centimeter cube. So I get the answer in gram per centimeter cube. Cool. Now I have to work for the uncertainty in density. So now, because the density depends on mass and volume, so we can say that the fractional uncertainty of density should be equal to fractional uncertainty in M plus the fractional uncertainty in the volume. That's the rule. This is propagation of uncertainty whenever uh, two physical quantities are getting divided to get the one physical quantity. Here I'm dividing mass by volume in order to get rho, right? So whenever division or multiplication takes place, to find out the uncertainty, we add the fractional uncertainties. So the fractional uncertainty in rho will be equal to fractional uncertainty in mass plus fractional uncertainty in volume. So if I solve it further, delta rho over rho is given 1.02 is equal to delta m, which is given 0.01 over m, which is 10.82, plus delta v, which is 0.2 over v, which is 10.6. So if I solve it using the calculator, I get somewhere around 0.0198. Okay, but now, very important, many of the students lose marks over here. So this is absolute uncertainty, and absolute uncertainty is always rounded off to one sig fig. So I will round it off to one significant figure, so it will become 0.02. So my final answer for density is 1.02 plus minus 0.02 gram per centimeter cube. So if I do this much, I get 2 marks. Okay, now let us move further to the next part. The next part says that state your answer in kg per meter cube and with correct precision. Now it's very important over here. I'll tell you what do they mean by precision whenever they write this. Cool. So let us convert our density to kg per meter cube. So I have density as 1.02 gram per centimeter cube. That means per 1 centimeter cube. Right? How to convert gram to kg? We divide by 1000. So I'm multiplying by 10 to the power negative 3. And centimeter cube to meter cube. So 1 centimeter, like 1 meter equals 100 centimeter. Right? In order to convert centimeter to meter, I have to divide by 100. But this is centimeter cube. Centimeter cube means centimeter times centimeter times centimeter. So I have to do it thrice. So I'll have to divide 1 by 100 into 100 into 100 in order to convert it into meter cube. So I get 1.02 times 10 raised to the power negative 3 over 1 into 10 raised to the power negative 6. So if I solve it further, I get 1.02 times 10 raised to the power negative 6 into this 10 to the power negative 6 goes up, becomes positive. So 1.02 times 10 to the power 3. which becomes nothing but 1020 kg per meter cube. Now, very important over here. Now we have to convert our uncertainty also, right? So uncertainty we got 0.02, right? So we have to so finally basically we multiplied our density with 10 to the power 3. So I will multiply the uncertainty also with 10 to the power 3 in order to convert this the same way. If you want, you can repeat the same process. Ultimately you will multiply by 10 to the power 3. So here you will get 2020, right? So now you see the value of density is 1020. It doesn't have any decimal point. That means now my uncertainty should also not have any decimal point. So plus minus 20, and it is rounded off to 1 sig fig, and the precision is matching. Imagine I would have got the answer as 10.10 1020.3. So then I would have to write 20.0. So this is what we mean by correct precision. So you need to match the decimal points of uncertainty with the decimal points of the measured value or calculated value. I hope I'm clear. Okay. Yeah, so now let us move to the third part of this question. Okay, so here we got the density, right? Don't forget that we got density as 1020 kg per meter cube plus minus 20, right? Of course this is absolute, so I can write 1020 plus minus 20 kg per meter cube, right? So this thing is very important over here. So now they have given a graph of density of water with the temperature. They say suggest whether the water sample can be considered pure. Okay, so now check at around you know 35 degrees Celsius, because if you see the question says when the density was measured the sample was at 35 degrees Celsius. So this density, the value that we have got is at 35 degrees Celsius. Okay, so now according to our calculation, the density at 35 degrees Celsius should be this. Okay, now let us see what does the graph show. So I will find out density exactly at 35 degrees Celsius. So this is 30 and this is 40. Somewhere exactly at mid will be 35. So around this point, so which I see as this is 990. 1, 2, 3, 4, 5. 5 boxes is a difference of 10. So one box is a difference of 2. So the value of this is 994 kg per meter cube. So looking at the graph, okay, so at T equals 30 degrees Celsius, density is 994 kg per meter cube according to the graph, right? Whereas the value that we have calculated, the calculated value is 1020 plus minus 20. That means the correct value of density lies somewhere between 1000 to 1040, right? And this value doesn't lie between these two values. This is smaller than 1000, right? So hence we can say that the sample is not pure. So here now very important that you refer to the data given, because they have used a command term suggest. Okay, you would suggest based on some evidence, right? The evidence is over here, so it's very important that you refer to the data. If you don't refer to the data and you just write it's not pure, you only get 1 mark. In order to get 2 mark, you need to refer to the data. Please remember, this is a database test. It tests your skill, so it's very important that you refer to whatever information they have given to you. Okay, so that was all about the first question. Now we'll solve the second question in the next video. Thank you.